Welcome back to my channel Kuluru Vineeth. So I'll be continuing the arrays playlist. So today's question is search element in the given input matrix. Okay, so this is what the question looks like. We are given in a 2D matrix and also given one target. So we should search for the given target in the input matrix and at the end return true or false. If element was found in the matrix, we should return true. If not found, we should return false. Okay, so yeah, so this is the question. Now coming down to the intuitional approach, straightforward, what I'll do is I'll take two loops and iterate through every element in the given matrix and compare that with the target element, and if they are matching, I will return true or else false. Okay, so let me write down that approach. Approach 1 using two loops. Okay, so let me name this as approach 1 and input would be list of integers and the target, which will be of type integers, and read type would be boolean since we are just returning true or false. Okay, and straightforward, what I'll do is I will take two loops, inner loop and outer loop. Okay, and now what I'll do is I will just compare the current element I am at with the given target. If they are matching, I will straight away return true here, or else I will return false at the end of the function. That means we have not found that, so at the end we return false, right? So this is a simple approach 1 for this question. Now coming down to the time and space complexity, since I'm using two loops to iterate through every elements in the matrix, so it will be order of n square, and coming down to the space complexity, it will be just constant space as we are not using any extra space. Okay, so let me write down that here. Time would be order of n square and the space would be constant space, right? Yeah, so this was simple and straightforward approach 1. Well, is there a way that we could optimize the time to some less time, I mean order of n square to order of n or less than that? Well, there's already a hint for us. Since the rows are already sorted, we can go ahead and use binary search with the help of the two pointers and do the required job. Okay, so let me write down that approach as well. Okay, approach 2 using binary search along with two pointers. Okay, so let me name this as approach 2 and input parameters remain same and also return type remains same. So first what we'll do is we will take, first we'll store row size and column size in two variables. Okay, let me name that as m and column as, and take two pointers and initialize row as a 0 and call as total columns -1. So straightforward, we'll do traverse the whole array using these two pointers. So we will do is we will take current element, that is matrix of row column, and we check this one with the given target, that is the current element we are at, we'll check with the given target. If they are equal, then we'll go ahead and return true. Else if current is less than target, that means we know that we have to go little deep downwards the given input matrix, so I will go ahead and increase row. Else the other condition will be current is greater than the target. So we have to go in search where the current will be less than I mean closer to the target, so that we have to go towards left side. For that I will decrement column. Okay, and finally if not found, at the end of this function we will return false, right? This is the simple and straightforward approach using binary search along with 2 pointers. Now coming down to the time and space complexity. Since we are traversing the whole matrix, so let's say rows are m and columns are of size n, so the space complexity, time and space complexity would be, time will be order of m plus n, and space would be just constant space since we are using just extra variables. So let me write down that here, order of m plus n, and the space would be order of 1 constant. Okay, well, this is approach 2. Well, is there any other way again? Yeah, there is already a binary search function, inbuilt function available in Kotlin libraries, where we will try to apply binary search on each row and see if the for the given target, if the index it is returning is greater than or equal to 0, then that means we found that element and will return true, or else will return false. Okay, so let me write down that approach as well, so that it will act as a reference for us for any further reference. Okay, approach 3 using binary search function. Okay, so let me name this as approach 3, and input parameters remain same and return type also remains same. We just iterate here given matrix. Okay, so what we check here is, for every row we check if the given target is present or not. If it is present, we will go ahead and return true, or else we will return false at the end of this function, right? So, and now coming down to time and space complexity, since we are applying the binary search on each row, so I would say the time complexity is order of m log n, and space complexity would be order of 1. We are not using any extra space, right? Well, these are the 3 approaches for this question. Now let me write main function and execute each approach and compare the output of each approach and see if they're matching or not. Okay, function main, and initialize the object of the above class I have created, that is search element in matrix, and write 3 println statements so that we can see output of approach 1 and approach 2 and approach 3. Okay, call respective function here, approach 1. I will take the same example which I have shown earlier, that is 1357, and other elements are 10, 11, 16, 20. Okay, in 23, 34 and 60. Okay, so let me put that here as well, right? And now the target is, okay, I think I should give here itself. I should close this, I think. No, approach 1. Okay, I should do it in in this and put here and then do this, right? So let me do the same for approach 2 and approach 3. Okay, just changing the naming conventions. Approach 2, here also approach 2, and here to approach 3, and here approach 3. Okay, so now let's execute and see what the output of each approach looks like. Yeah, so there we go. The output of approach 1, approach 2 and approach 3 are same, which is true, exactly what we expected. Since 20 is present in the given input matrix, they are correct. Yeah, so this is it for this video. Thank you so much for your love and support. Keep watching my videos. There will be a lot more exciting content coming up your way. Thank you.